We're going to end up actually going through some quick demos now. We're going to create a simple site, run it locally. I'll show you how to package that up, and maybe we'll even give you a little peek behind the curtain about what's going on. So here's where we do our first big content switch. So I'm going to go over to my command line, if I could find it here. And let me make sure I pull my script up here so I've got this right. Okay, can everybody see the, Brianna, can we see the command prompt window okay? Is that sharing all right or not? Okay, I'm going to assume, unless anybody sends me a message differently. Okay, we're up okay. All right. So you remember that bin folder had two files we were going to look at, the scaffolder and a packager? Well, the first one we're going to use is the scaffolder. The scaffolder allows us to leverage a template system that's sitting in the SDK to generate a very basic Windows Azure application. So I've already have a path variable in my environment to allow me to access it. So I'm just going to type in scaffolder. I need to run it. And I'm going to tell it I want you to put your output to my D drive. And I'm going to put it in a folder called Azure User Group. And I'm going to call it Sample App. And I hit enter. Yay, simple enough. Now, if we switch over to one of my other folders here, let me make sure I can find it. Actually, I might not have that shared yet. 1 second. So if we switch over here, we now have a sample app. This is the app I just created. We have a service config and a service definition file. These are going to be used by Windows Azure. The definition tells us that we have certain attributes about the application I'm building. The configuration contains the details. So maybe something like, here's the database I want you to connect to and go in there. The real important piece of this is inside the .web folder. This is the actual website I'm building. So in here, I can actually start by creating a simple little script. Get this created in here. Index.php. Yes, we want to change the extensions. And if I edit that, again, some quick change management or changing here. I'm going to add some code to this to create the simplest little PHP application I can. So there we go. A very simple, very basic PHP app. Now, if I was using a traditional world, what I might have to do is actually go through and install that into a web server and create a virtual directory and everything else for it. But through the magic of the PHP SDK, I don't have to do that anymore. I can actually run another command that will deploy this into a local Windows Azure environment I have available to me. So here's the command we do to do that one. We're going to use package. I need to create a package, and I need to tell it where the file is located that I want to package up. In this case, Azure User Group and Sample App. Now I also need to tell it when I create this package, where does it end up going? In this case, I'm going to put it in a similar location. I'm going to give it a build folder so I know it's a little bit different. So let's pause for just a moment right there. So with Windows Azure, all of my deployments focus around the nature or this idea of a package. The package really contains all of my custom property or my code, my binaries that are necessary to make my solution run. When I create those into a package, it puts them into a container that Windows Azure can understand. It'll take that definition to tell it what types of roles are in the application, how they should be deployed, any other special attributes, shoves them all up into the Windows Azure fabric, and lets it take over determining where they're going to get deployed inside the data centers. But right now, I just want to run it local. So we're lucky that Windows Azure includes a local development emulator. So just by adding this /dev equals true on the end of my package line, we can actually run this and deploy this locally. So we'll give it a moment here as it goes through and packages everything up. It's going to wait, so I have to respond to a couple of messages in the background where Windows is telling me or asking me if I really want to give this permission to do things. And now if I share this, Okay, well, what we should be looking at now is my web browser pointing to 127.0.0.1 on port 81. This is the Windows Azure application I just built. It's running in a local version of Windows Azure that's specific just to allow me to do my nice little development. Now, if we look at this, we can see this particular one is still pulling the PHP configuration file from my C:\Windows directory. We're referencing the PHP folder that's installed on my local desktop. That's all well and good. And if I take another step, and let's go over and look at the Windows Azure or the Windows information or IIS server. Let me find where I have it here. I've got it here somewhere. Oh, come on. Bear with me for a moment here. I guess I lost it. We'll reshare it. There we go. So if we look at Internet Information Services, or IIS, and what's shared out here, I can take this. Let's just do a quick little refresh in here. Oh, come on. I know you're in here. There we go. We can see there was a site added here that was not here before, and this is the local version of my IIS application. I can still browse to it, and when I bring that up, you would see the same IIS website we had before. The IP address is just a little bit different, but it's still the same site. I can even look at the folders that it's in and go down and browse where it lives out on the local drive system. Now, when I deploy this to Windows Azure, what ends up happening is there's a series of startup commands behind the scenes that will actually download and install PHP for me. So let's go look at those for just a quick moment. Search content again. So if I go back into this, into the bin folder, you'll see the bin folder for my PHP app contained a couple of extra things, including a command called install PHP. If I edit that one, you can see essentially here a bunch of PowerShell scripts that will go through and download and configure and install PHP for me. This is kind of the secret sauce that's behind the scenes that makes it all work. So when I deploy my application to Windows Azure, it's setting up a virtual machine, deploying my payload or my package to that machine, configuring IIS for me, and then it's also letting my package do some additional customization, in this case doing things like downloading and installing the actual PHP runtime. Pretty slick if you ask me, especially since I don't have to worry about it all anymore. So that's the first demo. Now let's talk a bit about storage. So we mentioned these earlier. Make sure I get this content set back right. Oh, come on, where to go? Here we go. All right. So Windows Azure Storage. What actually is all going on here? Well, it's a storage system in the cloud that's intended to be very scalable and durable, giving us a real high uptime. It can be accessed from pretty much anywhere on the planet. Best yet, you only pay for what you actually use of this. So if you say create a storage account but don't ever put anything in it, you're not actually charged for it at that point. Or you can put stuff in it and leave it there, and you're only charged for the amount of time the processing power it took to upload it in the form of a transaction and the amount of time it's sitting there at rest. So as I said, with Windows Azure, they went out of their way to make everything interoperable and really support open standards. So the entire API for Windows Azure Storage is REST-based. I can use it locally in my compute emulator or from anywhere on the internet and from any language that can create a Mac Shaw digitally signed signature. I've even heard of somebody creating a storage client in curl just to see if they could. And it exists in various abstractions we have available to us, namely tables, blobs, queues, and one we won't really talk about today called a drive. Now, there are some things about the storage account you need to understand. At its highest level, it's addressed using an account name. Now, that account name is something you specify when you create the storage account, and it has to be globally unique. Nobody else in the world can use the same account name that you're using. That way we have easy addressability. But you get to pick where that storage account goes. So let's say I wanted to have one sitting in the Northern US data center. That is the only spot my data will get shared to, unless I give explicit permissions otherwise for things to move around. I also can put that storage account really close to where my service is hosted. That would help reduce latency, as well as help me avoid any unnecessary bandwidth costs. And in the case of blobs, I can enable my content to be delivered via the content delivery network, allowing me to globally distribute things. Now, along with that account name, we also have a key, or in this case, actually 2 keys. Each of those is a 512-bit key. Let's see if I can switch over and show you what one of those keys looks like real quick. So hopefully you're looking at the Windows Azure Management Portal. I have an account here selected called Training. Now, if I hit the button here, we're going to actually see here in a moment the really long primary access key and secondary access key for the account. Feel free to go ahead and write these down if you feel the need. I'll probably end up changing soon anyway. Because the reason we have 2 keys is to allow us to do key rotation. Just like if you were at a hotel and you had 2 keys to the room, you could hand one key to a friend and you keep the other. But let's say your friend loses his key, you can still get access to your room even while you invalidate your roommate's key. So it allows you to regenerate either one and just keep swapping them around, supporting things like key rotation without you ever having to take your service offline, just so you can redeploy with the updated keys. There you go. Okay, back to the slideshow. And lastly, and one of the neat things about Azure Storage, you can go up to 100 terabyte per account. This is really just based on how much you think you can afford to pay for at, I think last account, what was it? Either 12 or 14 cents a gig. The numbers have changed recently, and I'm having a hard time keeping it straight, but fairly inexpensive for something that's going to be out there, highly resilient. If it crashes, you get an automatic backup and restore for it. I mean, it's to have that much storage at your fingertips is just phenomenal in today's day and age.